Hello everyone. In yesterday's lesson, we left off with trying to figure out how we could find an equation of a parabola just given the graph or given the table of values of that parabola. And the question was related to this problem out of your textbook. We had discussed the fact that the a value in the transformation equation controls whether or not, it actually controls a few things. It controls whether or not the graph is stretched or compressed, and it also controls whether or not the graph is a reflection upside down or not. So if a is a number greater than 1, the parabola will be stretched. And we talked about the fact that a being a number greater than 1 can be like 2, 3, 5, 6.6, 7.7. Any number greater than 1 will stretch the parabola. If the number a is a decimal between 0 and 1, then that's going to be a compressed parabola. So 0.5, 0.75, 0.3, 1/2 like as a fraction, 3/4 as a fraction, like any kind of fractional number that's between 0 and 1 will cause a compression on the parabola. And if a just happens to also be negative, then that would cause it to flip upside down. So if a is positive, the graph is a smile shape, and if a is negative, then the graph is a frown shape, if you will. The actual terminology for that is opening up or opening down. So a smile shape would be opening up, and a frown shape would be opening down. So I had generated this graph in Desmos, and we had looked at a few different things that would cause the graph, and I'll just actually go to Desmos right now to explain that again. So what we had left off with the other lesson is that I had said, well, normally our quadratic, let me just add another equation here. Normally our quadratic looks like this. Y is equal to x squared. But clearly this pattern here does not follow the smile shaped pattern. It is actually a frown shaped pattern. So on top of that, the vertex of the parabola, which is usually at 0, 0, is now up here at 0, 6. So I had mentioned, and it was this equation that we had left off with, if we add 6 to our quadratic, we will move the vertex up to where it's supposed to be. And then if we make the starting number negative, we're going to get a parabola that's going to be upside down. And we had adjusted the decimal value to try to get it as close as we could to the points. So if we make this 0.5, it's too narrow. If we went 0.75, it would be actually more narrow, so it's even worse. So we have to go to a smaller number like 0.25, and that's still not great, but it's a lot better than what it was. So how do we figure out exactly what the number should be? And that's what I'd like to discuss with you today. So as long as you're given the graph or the table of values, and you know where the vertex is. So we are able to put our k value. So if you look at the general equation here, which is ax squared plus k, the k value moves the parabola up by 6, in this case, to get our vertex in the right spot. But we don't know our a value, so we have to calculate the a value. Now you can do it with trial and error on a program like Desmos, but the question actually said to do it without technology, so I want to show you how to do it with algebra. Now here's how algebra works. If you look at this equation, there are right now 3 different variables. We're looking for the middle variable a. You cannot solve for a variable if you have any other variables in the equation. So we somehow have to get rid of, or not get rid of, but change the x and y into numbers so that we can actually get a all by itself. Now, how do we do that? Well, we have a bunch of numbers for x and y. We actually have 1, 2, 3, 4, 5, 6, 7, 8 numbers for x and y. Now there's one of those combinations that we can't use, and that is the 0, 6. And we can't use the 0, 6 because that's what this number is. So we can't reuse that one because we've already used it. But I can pick any other number in that table of values, any other number combination in that table of values. So you do need an x and a y. If I have the option, I would rather not work with negative numbers. So because I'm able to choose any number, so choose any coordinate. That's what we call an x and y combination. Choose any coordinate except the vertex to sub in for x and y. In the equation. Okay, so it doesn't matter which one you pick. I'm going to choose, I don't know, let's choose 4 and 1.2. Okay, so we're going to pick that one. So remember that the x is the first column, the y is the second column, but in the equation, the y is the first variable. So we're going to replace y by 1.2. We're going to replace x by 4, following the formula, and the rest stays the same. So now the only variable is a, and we need to get a all by itself. And this becomes just a question of regular algebra at this point. How do we isolate a variable? So we've done this a few times with different versions of equations. What I always tell my students is you're working your way outside into that variable. You do not follow BEDMAS when you're isolating variables. Now, I'm saying that there are exceptions to that rule, but in this case, we're not following BEDMAS. We're following algebra rules. And algebra rules say if you have something adding or subtracting, that's the first thing you usually want to get rid of. Okay? So this is a plus 6. We want to move it over to this side of the equal sign. So that means we're going to subtract 6 on both sides. I'll write out all the steps so you can see them here. And when you subtract 6 on this side, where the a is, then that just disappears, right? So it looks like we moved the 6 over to this side and subtracted 6. Now, I'm going to get my calculator out here because I'm probably going to need it, and I'm sure I could do 1.2 minus 6 in my head, but I just can't do it right at the moment because I'm thinking of other things. So 1.2 minus 6 is equal to negative 4.8. So this side gives us negative 4.8 equals a times 4 squared. So now we're going to get rid of the 4 squared. Well, let's do 4 squared first. 4 squared is 16. And this is a multiplication. So how do I get rid of a multiplication? I get rid of a multiplication by dividing. So we're trying to get a by itself, so we're not going to divide by a, we're going to divide by 16 to destroy the 16. 16 divided by 16 is 1. And my final answer is negative 4.8 divided by 16. And that gives negative 0.3. So we now know that the equation that matches that parabola is negative 0.3, where the a goes, times x squared, plus 6, and the 6 is where the k went. So let's go back to Desmos and try that combination and see how well it fits our points. So I'm going to change the 0.25 negative to negative 0.3 and bang on. That is exactly through those points. And we now have an equation that models that parabola perfectly. So if I wanted to know what happens at 2.5, okay, 2.5 is right here. Well, on the graph, there is no point at 2.5, okay? But I could now substitute 2.5 into this equation, and the equation would tell me exactly what that value is. So in this case, exactly how high that motion capture suit was. So let's look at another example, just so that you can see two examples of how this works. Now this is a homework question right out of your textbook. And it says, graph each relation, then represent the relation with an equation of the form y is equal to ax squared plus k. Now I'm going to show you that you technically don't have to graph them, but with Desmos you could do the table of values and at least see where all the points were, okay? But you technically don't have to graph them. What we need to do, and we're going to do letter A together, is we need to find the vertex, and that's going to give us our k value, and then we're going to sub in an x and y to find our a value. So those are the steps we always follow, okay? So if this was on a graph, we could just read the vertex right off the graph, but how do we do it in a table of values? How do we find the vertex in a table of values? Well, I want you to look at these points in the y column here. Notice how it goes -5, -6, and then -5, and then -2. Well, this -5 and that -5 are symmetrical around each other. And which point is in the middle of those two? That is your 0, -6. So that's how you can tell where your vertex is, because your vertex is always going to be smack dab in the middle of where the 2 points on either side start to repeat. Okay? So if I look over to this table, right here, there's a repetition of the 2 4s. That means that this is our vertex. If I look over here, right here is the repetition of our 2 -8s. That means this is the vertex. So the vertex is always the point that's smack dab in the middle of the other points. Now be careful, it does look like each one of those points has a 0 as the x value. That is not always going to be the case. That is just a coincidence in this case, okay? It's because we're looking at parabolas that are all centered at 0, like this, all right? So that's where the 0 is, and it's symmetrical on each side. But that won't always be the case. We are going to be moving parabolas left and right later on, so just be careful. It's not always going to be where the 0 is, okay? Just happens to be here. So if we're doing A, what we would do is we'd write the equation just like they say in the actual question, right? Write it in the form ax squared plus k. So ax squared plus k, and I'm going to replace k by what my y value of my vertex is. So the y value of my vertex for A is -6. Let me erase these here so that they don't get in the way. So the y value is -6. So we're going to go y is equal to ax squared plus -6. Now some of you are screaming at me, sir, could we not just replace that as a -6? And the answer is yes. But I just wanted to show you that we are substituting a -6 where the k is. But then when we look at a plus negative, you can just change it to a negative. So that's step 1 done. Step 2 is we now have to sub in our x and y values. So pick an x and y value, not the vertex, okay, and sub it in. Now, I keep saying not the vertex. What would happen if a student did choose the vertex? What would happen if somebody put 0, -6 in for the vertex? So if I do that just off to the side here, -6 would be our y, x would be 0, okay? Well, look at what happens. What happens when you multiply a 0 times anything? That just becomes -6 equals -6 because a times 0 is just 0. And yay, we know that. We know that -6 always equals -6. That does not help us find a. So that method, unfortunately, won't work. You have to use a point other than the vertex to be able to find your a value. So let's, I don't know, let's use 1, -2, okay, just to show you that it works with any 2 points. So -2 is my y value. One is my x value. And let's isolate for our variable a. So like we did before, it's funny that it just happens to be a 6 again, but anyway, this time we're adding 6 on this side, so it'll be -2 plus 6 equals a times 1 squared. Now, a times 1 squared is easy to do. Let's just save a step here by writing 1 right away. Now, because it's a times 1, we're actually not going to have to do much more. Let's do negative 2 plus 6, which is 4. Okay, well, it's times 1, but 1 times a is just 1. So you could divide by 1 to get rid of it if you want, but the short answer is you don't have to do that. If you have just a 1 times an a on this side, it just becomes a. And that means we've isolated our variable. So the final answer is going to be 4x squared minus 6. And if I graph that on top of those points from the table, they should match perfectly. So it's going to be a rather shorter lesson today because that's it. I don't want to go any further than that because I would like you to practice this idea of using algebra in order to find the equation of a parabola based on the transformations given a table of values or the graph. So once again, if the graph was given, you could just take one of these points and estimate where it is. But if the table of values is given, choose any point except for the vertex. Once you find your k value, which is the vertex, to sub in for your x and y, and then you're good to go. So hopefully with those examples, you'll be able to do the homework from tonight. There'll just be a few questions to practice.